Imagine a scenario where you walk into your favorite department store. You've just gotten a raise at work, so you have a little extra cash in your pocket, and you start picking out all of these clothing items that you'd like to get. You take them to the dressing room, and you begin trying them on. The things that you like, you go ahead and you put in one column. The things that you don't like, or maybe they don't quite fit, you put those in another column. And then the ones that you're undecided about, they go in a third pile. Now, imagine in this dressing room, there's also a smart mirror. And the mirror is able to observe the choices that you've been making and is now able to recommend to you other items in the store that you might like. There's even buttons there, so you can click on the items, and the sales clerk will be notified and will bring you that item in your size. Pretty cool. Now, what's really cool about this scenario is that it can exist today. The technology for it is already here. So my question to you is, how would you test this? In fact, this will be my question to you throughout the remainder of our time together. Take a moment. Think about it. Would you even know where to begin? There's a lot of smart, really wise people who I admire and who I respect who are talking about the future of testing and the impact that AI will have on it. My good friend, Paul Merrill, he says, machine learning won't necessarily eliminate testing jobs, but it will change how the work gets done. The World Quality Report says, we believe that the most important solution to overcome increasing testing challenges will be the emerging introduction of machine-based intelligence. And the good folks over at Applitools said, we'll see a trend where humans will have less and less mechanical dirty work to do with implementing, executing, and analyzing test results, but they will still be an integral and necessary part of the test process to approve and act on the findings. Now, I'm really excited about these new age tools and how they might help assist me in testing and automating. However, there is a little nagging voice in my ear. I imagine it's the tester inside of me that's saying, but who's testing this stuff? How do we know how it works and that it even works? Because I don't know about you all, but I watch the news and I see a lot of horrific stories that are surfacing because of this technology. And this technology is being used in more and more applications every day, applications that we are using on a daily basis. And I feel like there's a piece of the conversation missing when we talk about AI and testing. Sure, AI can help us in testing, but what about testing the AI? Applications such as Netflix. How many people use Netflix? Just about everyone, of course, right? Did you know that on the homepage, as soon as you log in, that page is showing you personalized recommendations just for you. And that's driven by machine learning. How do you know if this is right? This is my page. I know myself better than anyone else, and I can't necessarily say if any of this is right or not. So how would you test it? Especially when you're looking at other personas that are not yourself. So I took a closer look at my Netflix recommendations, and there was only one thing that really stood out to me as being really weird. There's this show in the States that's called Stranger Things, and it's a really popular show. Everybody watches it except for me, right? So I've never seen a single episode of this, but I saw this title of Beyond Stranger Things, and I thought, well, what is that? So I Googled Beyond Stranger Things, and Google told me that this is an after show that kind of talks about things that have happened in the show. So it has all kinds of spoilers and stuff. And it went on to say, if you haven't seen Stranger Things, you probably shouldn't watch this. So why is it in my recommendations? But hey, that's all I got. Other than that, I don't know if this stuff is right or not. Twitter uses machine learning for things like detecting spam on the platform. So how would you test something like that? For example, let's say you have this tweet that says, message us if you're looking to buy some followers, $2 per 1K. Looks like spam, right? I would say this is spam. How do I know this? I don't know. Maybe it's the keywords there. How does the machine know this is my bigger question. But if it's the keywords, then let's look at this tweet where it says, hey, wanna be celeb? You have a total of 2K fans. Why don't you go buy some followers? This is not spam. Rude, but not spam, right? So how is the machine able to detect this? And that better, how do we test it? IBM, they have Watson, which is their artificial intelligence engine. And Watson is brilliant, right? Can do small and big things. I went to a conference once, and Watson had made some brownies. And the IBM booth was giving out these brownies. Best brownies I've ever had in my life, right? And the way that Watson came up with the recipe was by examining a whole bunch of brownie recipes and picking out the best things. Had liquor and everything in the brownie. It's amazing, right? But they also use Watson for more serious things like healthcare. For example, Watson can take a cancer patient and that cancer patient's DNA and then examine that DNA against millions of records of medical literature and clinical trials to be able to come up with a personalized treatment plan for that patient. How do you test this? Can't really afford to get something like this wrong, right? Well, I could stand here and I could give you a bunch of theory on how do we test machine learning applications. But that's not really my lane. You see, I work in the trenches, and I think that I provide the best value for you when I give you my own personal experiences in the workplace. So, fortunately, I've had the privilege of actually testing machine learning applications, and I'd like to share that experience with you. Is that cool? All right. All right. So, once upon a time, I worked on this application. It was an advertisement recommendation system. And the way it worked is a third-party retailer could give our service their inventory of ads. And then, in real time, that retailer could make a call to us, a web service call, and essentially say, hey, I have this particular customer here. Might be identified by a customer ID or some attributes about the customer, such as this is a woman who's 21 years old. And our system would then look at their inventory of ads and be able to make a recommendation on which ad they should show that person, right? So the key ingredient in this system was the machine learning. So the more you used our application, the better we would become at recommending ads for your customers, which would improve the conversion rates for that retailer, all right? So I had to answer this dreadful question of, how do you test this? I was tasked to test this, not only test it, but write automated tests against it. I had no clue about this stuff. I never even heard of machine learning before this point. So I didn't really know what to do. And I began researching machine learning, and I found a bunch of literature about what machine learning was and the different algorithms and types of learning styles and blah, blah, blah. But you know what was missing? How do you test it? No one was telling me how to test it. So I had to, like Gwen says, go cowboy and figure it out myself. So right or wrong, this is what I came up with. The very first thing that I did was to learn how it learns, right? As testers, I'm not going to speak for you. Let me speak for me. As a tester, I was raised or brought up that you did not test something that was not already known. The expected result wasn't known. If you had a case like that, you could throw your hands up and say, oh, that's not a testable feature. And everybody was cool with that, right? In machine learning, nothing is known, right? The way that this stuff works is it gives you a range of validity. There is no exact right answer in what it might put out. So I went from a place where, hey, I add this item to the cart. The item costs $30. I increase it by 3. The subtotal is 90. Exact, testable, automatable. To now, this point of, okay, I send it a customer, which ad am I going to get back? Hell if I know, how do I know, right? So I began doing some looking into the code, talking to the developer. There was one developer, resident expert. He was pretty much the only guy that really knew how this stuff worked. And the rest of us were like his supporting cast. So I talked with him. This guy, like I said, I'm not a big theory type of person, right? I'm very practical. This guy is the exact opposite of me, very theoretical. So he would begin talking to me and all of this machine learning mumbo jumbo jargon that went clearly over my head, right? But that's okay. So I would dig through the code. I just kept trying to figure out how it learned. What I learned is that the machine initially doesn't know anything. When it has nothing, it would send ads randomly, right? Based on how the customer interacts with the ad. If they actually go on to purchase the thing, which we call accept, if they accepted the ad, then the machine would begin learning on that sort of behavior. Okay, this is a woman, 21, she accepted this kind of ad. And it would create what's called models about what it learned. And these models essentially would represent what the system knows. The system would then consult these models for future decisions. So, hey, this is what I know. You ask me something based on what I've learned, I'll give you some answer. All right? So that's what I had. So the next thing I needed to do is come up with a scenario. What was it that I wanted the system to learn? So I said, okay, let's do something really basic here. I would like the system to learn that women prefer the dress ad and men prefer the pants ad. Okay? So this was the scenario I was going with, and I had to then feed data to the system to learn this. The way I did that was I wrote a script. And the more data that the system has, the better it learns about things. So in my script, I said, what's a big number that's not totally overwhelming for me? So I went with like 2,000 customers. I would have 2,000 unique customers. And for each one of those customers, I would need to send a web service call to the system, giving it the customer ID, and all of these were unique, so these were new customers, and a gender. I went with male or female. Also in my code, I randomly generated the gender. So there was about 48 to 50% chance that it would be one of the two genders, okay? So it's about even, the two genders. I had 5 ads in the inventory, the dress, the pants, and 3 other things, okay? So because I had 5 ads, before the system learned anything, each one of those ads should be shown about 20% of the time. That would be random. And then I would need to actually accept something, right? So I started out thinking, okay, anytime I have a customer that is a female and the ad that serves as a dress, then I would go ahead and accept it in my code. But then I said, well, that's not really realistic. Like 100% of the time you accept the dress or men accept the pants. So I lowered that to 65. So 65% of the time where there was a match between the gender and the ad that I wanted them to accept, I would go ahead and accept it in my code. And then 2% of the time, I would accept the ad no matter what it was or the gender of the person, because I wanted the system to go ahead and create models for all 5 of the ads. All right, you with me? All right, so I ran the script, 2,000 web service calls. I had to create this complex data structure in my code to be able to hold all this data. And the data structure resembled something like this table, right? So these were the 5 ads in the first column. The second column, that's the women who saw each of the ads. So you see that it's about 200 women for each one. So that was the random, looking good. The third column, the women who purchased. So in my script, of the 202 women that saw the ad, 133 purchased it, and then 3 or less of the other ads. For the men, about 200 for each ad, so that was fine. And then for the pants, of 196 that saw the pants, 128 accepted, and then 3 or less for all the other ads. So this was my training. This is what I gave the system to learn. So then I needed to test this. Okay. Now, I'm working in an automated script. Again, there's no exact answer here. So I don't really know what I'm expecting, right? There's no assertion that I feel comfortable writing because I don't know. So I began to think about it and say, well, how about I use the POX method? The POX method is plain old common sense. And what the POX method told me is that, hey, before it learned something, it would serve the ads 20% of the time. So after it learns something, then the women should be served the dress ad more than 20% of the time. The men should be served the pants ad more than 20% of the time. And the other 3 ads should be less than 20% of the time. That's all I had, right? So I would run this and then let's just see how it goes. Okay, so I ran again, 2,000 new customers, right? Not the same ones, new folks. Again, using the same male and female. So this is what I got back. For the dress, there were 202 women who saw the dress before the learning. And then after the learning, 890 women saw the dress. Yes, looks like before, greater than random, right? And all the rest of the ads for the women were less than 20%. Looking good. Then I looked at the men. All right, so the men, 196 men saw the pants before learning, but then only 59 saw the pants after the learning. Then I looked at the dress for the men. There were 204 men that saw the dress before, but now 874. So that doesn't seem right, right? So I began asking, oh crap, what did I do wrong, right? I don't even know why they asked me to do this machine learning stuff. They know I don't know what I'm doing. And I began beating myself up. And because I'm an automation engineer and we like a good retry, I threw all the models out and ran it again. All right? So I ran the thing again. And this time, I got different results. This time, the men did see the pants more than 20%. But guess what? So did the women. So I'm like, what is wrong with this stupid thing? So I start going through my code. Clearly, I must have goofed something up with the training. So I'm looking at it line by line and trying to figure it out. I throw all the models away again. I run it again. Same kind of flip-flop, but not in a pattern or anything. You know, it might be women see it 2 times or whatever. So I said, okay, let me look at the data structures and kind of study these tables to see if I can figure out what's going on. So what I realized is that because I'm doing the genders randomly, there wasn't exact like 50% men, 50% women. It could be like 48% women and 52% men or something like that. Whichever gender happened to be greatest during the run, that's the ad that the system was learning was most popular. And it would show that to everyone. So the system wasn't actually learning on the gender at all. So I thought, okay, I found a bug. This is a good one, right? So I wrote the bug up. This was unlike any bug that I've ever written up in my life, all right? So I'm used to, you write a little description about what happened, and you put the steps to recreate the problem. Actual result, expected result. If I'm feeling really generous that day, I might throw in some logs and some screenshots. This time, this took me hours to write this up because I had to go through all the rationale behind why do I even expect a certain thing. How did I set the system up? And so I basically had to go through my algorithms and things that I had written to tell how I taught the system, what I think it learned, and why. So I opened the bug, felt good, right? It's a good day. I found the highest severity I opened that thing at, right? And then guess what? The developer closed my bug, y'all. You won't believe what he said. He said, well, it works on my machine. So I was crushed. But after I got over my ego, I said, all right, works on his machine. Let me go over, talk to him, and see how he set it up. Because I know I did something wrong, right? I was never really confident. So I went over and I talked to him. And I said, hey, you got this working on your machine? What'd you do? Tell me all about it. He says, well, not exactly that scenario, but blah, 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 jumbo, all of this technical jargon, right? Again, speaking over my head. And so I said, okay, I've had enough of this day. I'm going to go home, and I'll come back tomorrow with fresh eyes. So I went home, could barely sleep for thinking about this bug and my setup and trying to figure out what I'd done wrong. So I came back the next day. I went through my script again, couldn't find anything wrong, deleting models, running it again, blah, blah, blah. Called my team lead over. I said, hey, take a look at what I have here. Did I goof up? Why do you guys have me doing this anyway? He said, stop it. He said, you've studied this stuff. You know it just as well as anyone else here. It's a bug, Angie. So I reopened the bug. Resident expert then comments on the bug. Again, all of the mumbo jumbo about machine learning and all of this fancy jargon. It sounds really smart when he talks, And I commented and said, it doesn't work, right? So the bug just stayed open for several weeks until it became time to ship. Now, we can't ship this thing with the highest severity bug open. So the product owner thought, oh, well, I better humor Angie and let's set up a meeting with Angie and resident expert and discuss. So the meeting went something like this. Resident expert gets in there with his fancy mumbo jumbo. When this guy talks, I tell you, you believe what he says, right? And so he's talking about the theory of machine learning and all these algorithms and, oh, learning is working on my machine and yada, 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 right? And so once he was done, it was my turn to plead my case. I took a different approach this time. Instead of talking about how I set everything up and what I expected, I said, listen, here's the deal. We have a customer who has a shop. Men are coming into the shop. They are buying the pants like hotcakes, right? Our system is observing that behavior, and then we think it's a really good idea to keep showing all the new dudes that come in dresses, even though they're buying the dress 1% of the time. But we just keep hammering away with the dress ad. I said, the customer is going to think our stuff doesn't work, which it doesn't, and we'll lose business. Do what you want. So once I said this, everyone, eyes opened, right? Like, okay, we get it now. So product owner says, hey, resident expert, run her scenario on your machine, her exact one. So resident expert says, okay, but blah, 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 blah. And he changes things and he finally runs my scenario on his machine, and guess what? It doesn't work. So he turns red and he says, oh, I don't know why I doubted Angie in the first place. And that felt pretty good. So, what did I learn? I learned that as technology advances, so must our test approaches. So some things that we've learned, that we've taught, that we talk about on Twitter as the rule, the golden rule, and you can't test if you don't have this or you don't know that. All of that stuff was challenged in this scenario. Some things that I thought were rules were no longer rules in this context. So as we advance our technologies, as we look at more and more of these things, some of our beliefs are going to be challenged, and that's okay. We have to advance. I also learned that the need for automation became much more apparent. Now, in order to run this stuff, I picked an arbitrary number of 2,000. Well, I don't want to run 2,000 web service calls by hand and then the results, write them in like some Excel spreadsheet or something like that, right? So I needed to actually script this stuff out. And the automation was much different than stuff I've done before. So I consider myself an expert in like Selenium WebDriver, right? But there was no interface here. There was no UI. So that was out. I had to do straight up programming to be able to actually set this up, to get the data I needed, to store that data, to do comparisons within the code. So that was important. But there was still a need for thoughtful and critical testing. Now, I'm all for encouraging people to learn how to code, but we don't do enough of encouraging people to learn how to test. Programming is not enough. Remember, resident expert, he knows how to code. He knows machine learning, and yet he was ready to ship this thing without the most basic scenario working. So, a lot of times people say, oh, once we get these AI tools, maybe we won't need testers. I call BS on that. I think we'll need them even more to do this critical and thoughtful thinking. And I learned that plain old common sense can still trump an algorithm, right? So as much as resident expert was talking about machine learning and the algorithms and using these big fancy terms that were over my head, plain old common sense is what got me to the bug. I could have given up and said, oh, okay, I guess you're right, and closed the bug, but no. I used the POX method. I went into that meeting with the POX method to make people understand. Because I don't care how smart these systems become. I don't think that it's ever smart enough that it doesn't need our intervention as testers. Someone has to continue to question and interrogate these systems and advocate for the human users. Because in my case, if it didn't work, if we shipped this, the worst thing that would have happened is that the businesses would have realized that we don't actually work, and we would have lost money. And maybe they would have lost money. Seems like a big deal in business terms, but in the grand scheme of life, it's not that big a deal. But we're using this sort of technology everywhere in cases where it is life or death, such as in autonomous cars. Now, there's the old trolley problem. And I saw this guy, Paul Fenwick. Paul talked about this at OSCON last year. And he did such a colorful job of describing the trolley problem. So I brought Paul here today to talk about it.
As you all know, for anyone who has read anything about autonomous vehicles or spoken about autonomous vehicles, it is required by law that if you are going to give a talk about one of these things, you have to mention this thing called the trolley problem. So I'm going to get that out of the way right at the start. So I want you to imagine that autonomous vehicles are real. And it's really interesting because 2 years ago when I gave this talk, people were like, oh yeah, they might happen, they might not. People would keep telling me that autonomous vehicles would be a long time coming. Now we're starting to see them on the actual roads. So I want you to think that forward into the future. Imagine that you have really smart autonomous vehicles and you have this situation. You have a cliff face with a single lane that's been carved out of it, and you have a car with an occupant, there are no longer any drivers, who was in that vehicle driving along the cliff face. And there's no place to swerve, there's only one single lane. And quite unexpectedly, a child runs out into the middle of the road chasing a ball and trips. And the car is driving at such a speed that it is unable to stop in time to avoid a fatal collision. Now, if you're wondering how could this possibly happen, the child forgot to carry their personal tracking device, so the car was not aware that they were around the corner, and they were hiding behind some sort of terrain. They were behind a rock or behind a tree. The car did not see them. So the car is going to hit this child. The child will die if that happens. But the car has a choice. Rather than hitting the child, it could choose to throw itself off the cliff. And it's a long, long way down. It would be sacrificing itself and its occupants to save the life of the child. And of course, the question is, should it do this? And some people will say, yes, it should, and some people will say, no, it shouldn't, and lots of people will say, oh gosh, that's a really hard question. How about we talk about something else? That's the most common thing I get, people telling me that, no, this is not possibly something that could ever happen. But let's pretend there is a child there, and you might say, maybe not. But what if there are 2 children in front of the car? Or what if there are 5 children in front of the car? I would hope at some point there is a sufficiently large number of children's lives at risk that you will say, yes, the car should throw itself off the cliff. It should sacrifice itself and its occupant. So this is like the standard introduction to machine ethics, trying to convince machines to act in an ethical way. And I find this particularly interesting because we can't agree with what human ethics should look like. I have these interesting questions as to how we should act and what is actually considered to be good. And trying to talk about a machine in this sense is really interesting.
So of course, my question to you is, how would you test this? You know, I don't think that my job as a tester is to necessarily fight to get bugs fixed, right? I think my job is to present information to the team. This is what we think we're building. This is what we've built. Here are the discrepancies, right? And to do that, I might have to ask some questions. So as a tester, I think that the questions are going to get harder as we start looking at systems like these, right? I might have to go in and say, hey, are we killing children or what? Right? And basically make sure that everyone is aware of what our intentions are and we come to an agreement on this. So let me simplify this so that we're not killing children. Let's say instead of children, it's maybe an animal in the street, maybe a deer, right? So I asked the question, hey, we have a case where we have an animal in the street and we have human passengers. Do we kill the animal or are we jumping off the cliff? Right? What do you all say? Save the human? Okay, one person. Everyone else is afraid to kill this deer. Okay? I'm going to go with you. Let's say, huh? I'll take my chances. So, let's say as a team, we have this discussion and we decide, okay, we're going to value human lives over that of animals. That's the decision that we've come up with. That sounds fine in theory, except we have stuff like this that happens. So there was a case where Google misclassified images, and they thought that the black folks were gorillas and labeled them as such. Now, a couple of people are laughing, seems like just a cultural taboo, but when we look at this in the instance that we just described, now we're killing black people in the street. I'm sure that's not what anybody wants, right? So, as we look at this stuff and it becomes life and death, there's a whole bunch of areas that I encourage you to look into. The ethics, right? The bias. There's privacy issues. There's security issues. And there's just the functional stuff like I talked about today. Whichever one of these is your cup of tea, I just encourage you to explore it more. Since the time that I've tested machine learning, I've worked at companies that are using machine learning for other features. And it's really common for development, for tests, for the product owners, the managers. Everybody is like, oh, that's a machine learning feature. We don't need to test it. And everybody is okay with this. Everybody is looking at this as this magical black box that just works. Of course, we know that's not necessarily the case. So, testers, if you are ever in a situation where you hear that sort of rhetoric, challenge it. Say, no, I think we should test it. Okay? So, it's not technology that is far into the future. This stuff is here today. So I beg of you, my friends, to please, please test it. Thank you.